maybe. Okay, it will be helpful if yeah, we can share the video later. Okay. So yeah, so that's my background. So that's why I'm presenting this topic. So I hope that maybe if I have more time and all, I can present more on this topic. Because I know many people are interested in artificial intelligence and so on. So that's why I just called this part one. Yeah, but hopefully, yeah, I'm also busy most of the time. So when I get some free time, I can continue the remaining parts. Okay, so if you see AI, it has many branches, like you can see here. So machine learning, yeah, the inside we have deep learning, supervised learning, unsupervised learning. So yeah, then deep learning is just neural networks with many layers, and supervised, unsupervised um, is it's a training methodology, how we train this algorithm. Yeah, then AI can be applied to NLP, natural language processing also. So if you see here, content extraction. um, so like for this is just AI helps to automate many things. Okay, that's why AI is very powerful. um, so if let's say you have many forms, the feedback forms, and then you want to check how many forms have negative comments or negative feedbacks, then you cannot be reading every single one of them, right? So then you can extract like negative sentiments and things like that, so it can be helpful for that. It's helpful in machine translation, text generation. Actually, AI can even write books. uh, like now they are there is AI which can write Shakespeare's novels. So they train it on many of these previous versions of Shakespeare's novels, and then they ask it to generate, and it will follow similar patterns to Shakespeare. Then we have expert systems, and then computer vision. It's also highly used in computer vision, like image recognition. Like how our brain can look at an image, and then it can make sense of the image, like it is this object, this is yeah, and perception. So uh, so AI can help to do that. Then when it comes to speech, for example, related to sound, yeah, so it can convert speech to text. Like in YouTube, if you see, they have this transcribing feature. So if somebody is saying something in the video, it immediately converts to text and displays on the bottom. And actually, this is algorithm that is doing it. I believe it's in real time, because when you run the video at different speeds, actually the translation will be different at the bottom. It's not translation, sorry. The transcribing of what the person is saying will be slightly different. So I believe it's all happening in real time. It's not like one time they spend time to record what the guy said, and then then they attach it to the video, and every time the video plays, it repeats. It's not like that, I think. Yeah. Then other fields also, like robotics, planning, and even in like operations research and all, they are using AI now. It's so things like reinforcement learning, yeah, all this can help. Okay, so it has broad applicability. So if you have any interest in any of this, then learning AI will definitely help you in some way. Okay, so let me just talk about the power of AI, just to give some motivation, about AI and things like that. So if you see this, this is a video of a hospital, and if you see here, an AI algorithm is running to detect people, detect objects in this image. So like actually I did the project related to this kind of hospital setting where I was creating a, AI based fall detection system. So in a hospital, if most people come there sick, and then um, if they are very sick, and sometimes they can faint and they can fall down. So if we have a camera that can detect a person falling down, then you can immediately alert the hospital staff, and they can come and take a look at the person immediately. So in my university, that was the project I was doing. So before we can detect falls or something, a person falling, right, we have to first detect a person. So if you see this video that I'm playing here, that's what this algorithm is doing. So there are these called object detectors. Okay, so I have given the GitHub links. You can go and check the demonstrations of these frameworks. Yeah, so these are like object detectors, so it's detecting person, chair, handbag, and things like that. Yeah, then on the video here, this is me actually. So I'm walking. Yeah, and yeah, then I fall down. Yeah, I fall down like this. So then you see it is detecting that I have fallen down, so it is indicating a falling. Yeah. So um so basically what happens is, after it the the algorithm knows I'm a person, then you see these lines on my body. So these are actually called key points. Actually the points are connected by the lines. So the human body is like split into many key points. I think not many, 32, around 32 key points. Then what happens is, this pose detector. So after we detect person, then we can detect pose. Then so there is this called alpha pose. So what this does is, it detects the key points in this entire frame, where's the person, and then the key points at which pixel in this image. Yeah, then it gives the output as the pixel wherever the key points are. After that, what I do is I will pass that key points into this thing called LSTM, which is another algorithm. It's called recurrent neural network algorithm. So what this does is, it checks the sequences of the key points coming out from each frame of the, because this is a video, so it has many frames of images. So in every frame there will be certain key points. If you see the sequence of frames, like the sequence of key points, then we can say that if the sequence is like this, that means there is a fall happening. So if when I'm standing, the key points around my head will be at a high value, right? And then when I fall down, the key points around my head will be at a small value. Yeah, but the thing is, you can write a rule, right? You can even code this. You can say if the head is within some thresholds, and then when the head key points go below certain threshold, consider it as a fall. Yeah, but there are problems with that, because let's say falling now, I'm falling sideways. What if I'm falling to the front like this? What if I'm falling in some other orientation? So that's where the rule based algorithms will not be very good, because you cannot, like, for every instance you cannot have a rule. Yeah, that's too much. So that's where, like, AI can be very helpful. It has very good generalization capability. That means you train on certain things, it will see something similar to this and also understand that they are both the same thing actually. Yeah, so that's the power of AI. Okay, so if anybody has any question, you can just stop me immediately and you can ask. Okay, I prefer to have a very interactive kind of presentation. Yeah. Okay, so here just present some more applications. So for example, mainly actually AI started with these two tasks, that is classification and regression. So classification means, let's say you want to distinguish between different classes. So for example, if you have emails, you want to distinguish some emails as being normal emails, and other emails being spam emails. So so this is a type of classification, spam versus non-spam. Or you can also have, like, given an image, you tell me if the image has a cat or a dog. So this is also classification. If the image has a cat, you say cat. If it has a dog, you say dog. So you have to classify into different classes. Yeah. So one example is fraud detection, for example. So like example, email. Yeah. uh, so this is not the only application. Like many credit card companies, they also use AI to detect fraudulent transactions, or yeah, if somebody is uh, using a credit card in a very abnormal way, something like that. So how do they do it? Okay, to simply put, um, what they have is, they have a certain number of features. So if it is a fraud, spam type of emails, then you will have certain features, like there will be something unbelievable in the email, like the person is going to give you $1 million or something like this. So these are like some features that you have to extract from these kind of emails. Then if certain features exist in certain emails, then you consider them as a spam, and if not, then it's non-spam. Yeah. So from what I told you, it looks like I'm telling a rule-based type of algorithm to distinguish between the spam and non-spam classes, but it's not exactly like that. So I can explain more later on. So it is not a rule-based algorithm. So even if you show something that you have not used for training, it can still correctly predict if it is a spam or non-spam. Okay. So then another problem is called regression. So regression means something like time series forecasting. So time series means it's just a sequence of numbers that is over some time period. So if you see here, this is time, this is years, for example, and the y-axis is stock price. So let's say this is some Tesla stock or some company stock, and if you see, uh, you cannot use any mathematical function to model this. Actually you can, but the function will be very complicated, right? It will be like a very high order polynomial function, or you have to have piecewise function or something like that. It will be very difficult to model something like this. Like if you had a line, then you can use the equation of a line. If you had a parabola, you can use like quadratic equation. If you had a cubic equation, you can do. But once things become super complicated, like something like this, then like equations and all don't really work that well. Okay. So why I'm comparing with equations is because a neural network, or this AI they are talking about, right, is actually something called a function approximator. So you give some inputs, it will give you some outputs. So it is just like a function, but that function is very highly nonlinear, and very uh, uh, it's a function that can capture a lot of non-linearities, like in this curve that is shown. It's changing very abruptly, high, low, and things like that. Yeah. So this, if you see this orange is the prediction, and this blue is some historical data, and then the green is the actual actual thing that happened. So You might be wondering, like, actually, there is no pattern like this in the history. So how can it suddenly generate, something different from the pattern that's previously? Okay, because it is not only this algorithm not only incorporates the historical data, it also incorporates some present information. Like if there is a, let's say, like this company is they had a merger or they bought over some new company, so they have new market potential. So then it uses the present information and past information, and then it makes a prediction. Yeah. Okay, then, like in natural language processing, yeah, it's mainly based on this recurrent neural network. So recurrent neural network means the inputs will be some sequences. So for example, if you have a sentence, like in machine translation, when you tell a sentence, so the sentence is sequences of words which are actually linked to one another, right? They are not some they don't have any relationship or anything. Each word has some relationship with another word next to it, or two words away from it, something like that. So for those kind of tasks, there are type of neural networks called recurrent neural networks, which are very good. So some of the applications are like machine translation, chatbots, like you see in the bank or somewhere. They are all out trying to avoid like human call centers now. So they are using chatbots now. Yeah. Then even code generation. Now AI can even generate code. So maybe I'll show this video. It will be a bit applicable to everyone, because I think many of you people here are coders and software engineers. So I'll show this video of how AI can generate code. Okay. So that means you give some text, you just comment, like for example, add uh, add number x to y, or x plus y, then give the output. Then it will define the variable x, it will define the variable y, then it will do write the operation for x plus y, then it will store it in z, and then it will print out z. So it can do all these things by just telling verbally to the to AI. So it is just like we take exams. So in the exam paper, they will give you a question in words and convert it to code. So now AI can just do it automatically. Okay, so before we go into that, I just want to explain one thing in that they use in this video. That is this word called palindrome. So basically, a palindrome is just a string that reads the same in both directions. So, for example, if you see madam, M-A-D-A-M, if you read from this direction, it is M-A-D-A-M. If you read from the right to left, like if you read Arabic, M-A-D-A-M. So it is still the same, right? So such words are called, or such strings. So it can be numbers also, like 1, 2, 3, 1, 2, 3, 3, 2, 1. Yeah. So it reads both from both the same from both directions. Okay. So I'll just show this video. It's very nice, actually. I don't know if you can hear it. Can you hear the video?
No, we can't hear it.
Okay, you cannot hear it. Okay, okay, then maybe yeah, maybe you can watch it later. Okay, so it's only 4 minutes. It's a very short video.
Yeah.
Yes. Okay, so yeah, I think you can watch it later. This is just about like how this guy will just write. You see, he just writes this comment, and everything else below this comment is actually generated by AI. It is not written by this person. Yeah. So it's he just writes more and more complicated functions, and the AI is able to like understand the complexity in the comment that he writes. So that's what they try to uh, like it says return list indices of the elements that are palindromes. So some words, if the indices on the left side and the right side are like complementing each other, like matching, then it will return the index, I think. Yeah. So you can watch this video. It's in the link is given. So it is very very interesting. So yeah, okay. So maybe we can move on. Mm, this okay. I'll close this. Oh no. This okay. Yeah, so if you have any comments or questions, you can just talk to me directly. It's okay. You don't have to wait until the end. Okay. Okay. So, okay, then that is for like natural language processing application. Now is for computer vision application. So, um, yeah. So, for example, you don't, okay, we don't need audio for this. I can just play this. Yeah, you see this person. Actually, it looks like he's wearing some spectacles, but actually these spectacles are not physical spectacles. They are virtual spectacles. I can just extend this. Yeah. Okay. Can show. Let me see. Okay. Yeah. So you see, he's wearing some spectacles, but actually they are not, yeah, physical ones. So yeah. Okay, so that is actually this application. What is that? It is a computer vision application of how they. It is something like my project that I talked about here. So basically, what they do is they first detect the face of the person, and then they will track where the face is going. So yeah, before they track, they will see all the key points. They know where the nose is, they know where his ears are. Yeah, then then they will draw the shape of the spectacles around it, and then they also track his face, where whenever he moves his face. Yeah. Okay. So okay, maybe yeah, now we'll go into a bit of depth. Like, okay, so what is AI? What is happening? So I just said under the bonnet of AI. So inside all of AI is something called neural networks. Okay, so uh, yeah, this is actually very similar to what's in our brains. Our brain also has like some 85 billion neurons. It is so much. It is so yeah, and the number of neurons we have in computers and all is kind of less. Although although we can code them to have more, but many of the applications that we are using, it's nowhere near like 85 billion neurons that is in our brains. Okay, so basically what it has is uh, so if you see, this is actually a neural network, and in this neural network there will be some inputs that will go into the network, and then there will be some outputs that will come out of the network. And in the network you have neurons. So these things are called neurons. You can think of them as like processing units or something like that. And then you see these interconnections, these lines that are connecting. So these lines are called weights. Okay, what's this? Yeah. So these lines are called weights, and what happens is every input, if you see, will be connected to every neuron in the next the proceeding layer, and every neuron in this layer is connected to every other neuron in the proceeding layer. So they have all the interconnections like this, and when some input goes, some neurons will fire, and they will result in some neurons on the output layer, output neurons to be fired. So for example, let's say we are doing the spam email classification. Okay, so this output, let's say this output is spam output. So if you have an output in this from this neuron, then that means it's a spam. If you, okay, and this neuron can represent non-spam. So if you have an output from this neuron, then it's considered non-spam. And you send some features of an email inside here. So it's feature 1, feature 2, feature 3, feature, yeah, and this feature has some value, okay, some number, numeric value. Then it goes into this neural network, and if it's if the characteristic of that email is a spam type, then this neuron will get fired, and then we know, okay, it's a spam. And then yeah, if not, this will get fired, and it's non-spam. Okay, so so let's just like it's going to be a bit detail. Yeah, so I will explain some terminology. So this thing is called a neuron, or it's also called a perceptron. Yeah, they are used interchangeably. Then these connections are called weights. And this very first thing, set of these are not neurons, these are inputs, so it's called the input layer. Okay, and this everything after the input layer is called a hidden layer. So this is the first hidden layer. So if we have a few more, then it will be called the second hidden layer, and so on. Then the output is called the output layer, okay, with output neurons like this. So this diagram, you can see the weights that I mentioned. So the input, yeah, feature 1, feature 2, so 2 features, and then the weight connection. So this is also numeric value. It's a numeric value. Then this is a, yeah, hidden layer. Then there are also weights going from here to, so this is like a single output. Yeah, so actually this also can be used to represent the same problem I was talking about, the spam classification. So instead of having 2 output neurons, you can just have 1 output neuron, and if it is 0, you consider it as non-spam, and if it's 1, you can consider it as spam. Yeah. So so the type of inputs that go into this and these networks, so I have given example here. So let us say we are going to we are going to do a classification problem. And in this problem, we want to classify how much premium to charge a driver. Okay, so insurance premium. So let's say, if you have a car, then you have a car insurance, right? And yeah, you have a car insurance, and not everybody's insurance price will be the same. Yeah, so before you can assign the price to the person, you have to classify how much risk this person carries. Okay, so let's say we have some data, the insurance company has collected some data from their customers or their prospective customers. So what are some of the information they might have? Like, for example, one important thing is if you see a drinker or not. So yeah, because we know like drinking and driving causes a lot of accidents, right? So then age. So usually a younger person is more more wild and likely to cause accidents. Yeah. Then average speed. So if you drive fast, you're more likely to cause accident. Then type of car you own. If it's a sports car, then yeah, more likely you will speed up and might cause accident compared to a normal car. And then do you have a family? So if you have some like if you have a family, you'll feel more responsible, right? So your actions will be more responsible type of act. So that's also an important factor. So these things are called features. And then the thing that we want to classify is called a target, or this is going to be the prediction, something like that. Yeah. So let's say this table was done by a human being. Okay, so that means this data is like already available and it is correct data, and this is called a ground truth table. So that means everything in this table is true. So the insurance agent or somebody has already classified this table correctly. So like if it's a drinker and if it's of a young age, then drives very fast, and then has a sports car and no family, then this person is considered high risk. Yeah. Then like for example, this person is a drinker, he's a young person, but he drives very slowly. Okay, and he has a normal car and he has a family. So we think that this person is still at low risk. Okay, so so we do this kind of a table, ground truth table, and then we 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 classify it by ourselves using our human knowledge. Yeah. So then these things here, these features are going to be like the inputs going into this network.